Hello and welcome to a ramble with me. Today we are looking at IEB paper 2 from May 2024 and we are looking at question 8 in particular. In the diagram the following is given. Okay, let's get my pointy. C with coordinates 6, 3, so that guy over there, is a point on the straight line BCD with B on the x-axis and D on the y-axis. Cool. A is a point on the x-axis so that AC is equal to CB. So we've got an isosceles triangle going on here. Okay, the gradient of AC is 3. So I'm just going to make a note for myself here that M is equal to 3. Wow, that's a horrible looking note. Let's write it in a way that would make my mother proud. Okay, right, cool. So the first question says, determine the equation of BCD. Whoa. How? How do I do it? Okay, let's see. So we have C, a point on this line. We know that, we know that AC has a gradient of 3. So we can definitely determine the equation of this line. What would that be helpful for? I don't know. Maybe it would be helpful so that we can find A, the x-intercept, and then we can work out this length, and then we know that this one also has the same length. Then we can try and see, which point other than A is the same distance from, which other point has this distance from C? Which other point on the x-axis has the same distance as A is from C? Do you get what I mean? Equidistant. That's kind of what I'm trying to say. Let's see, is there a simpler way to do this? Potentially. So I feel like maybe we can draw. So the reason why I feel like maybe let me draw this line is I'm feeling like, maybe congruent triangles. If I draw like perpendicular line here, then these two triangles are congruent because of RHS. We've defined this to be a perpendicular line to the x-axis, so that's a 90, that's a 90. These two are the same length, and this is a common side to both triangles, so RHS is satisfied. So what is the purpose of, how can this be useful to us? Sad face. Well, maybe it's useful to us because if we can find, we know that this point over here will be 6 and 0, right? It's straight beneath the C. So they have the same x coordinate, the y coordinate will be 0. So if we can find the coordinates of A, then we will know this distance. And then from there, we can work out this distance. Well, not work out, we then know this distance as well because congruent triangles. And then we will know the coordinates of B, and then we will be able to work out the equation of this line. Well, so what is the moral of the story? The moral of this story is, I don't know, out of fun, I'm going to do it both ways. So of course, my brain is very paper 1 oriented. So my initial solution was very algebra leaning. I'm actually surprised that I've come up with a solution that's more geometry than algebra. But anyway, so let's do approach number 1. Right, so we said we want to, so we shall construct, and we'll call it point M, such that CM is perpendicular to the x-axis, right? So therefore the coordinates of M will be 6, 0. Okay, then for triangles CAM, so this is our M here, and triangle CBM, the following is true. So we said CM is a common side. Okay, okay, maybe I shouldn't be using dash bullet signs in maths, confuse us for a minus. AC is equal to BC, which has been given to us, not BC, yes, it's BC, haha. Okay, and then finally, CMA and CMB are 90 degrees, right? One is given and the other one is kind of, oh yeah, it's both given. The fact that the line is perpendicular tells us that. So the fact that CM is perpendicular to x-axis, right, tells us that whether you look at, hey, come on, little s, you can do it. What are you doing, little s? Too confident, too confident. Somewhere here. Okay, right, so what I'm saying is the fact that this one is perpendicular to this, so it's a 90 degree whether you look at it this way or you look at it this way. Okay, right, so then what does that mean for us? That means that, therefore, triangle CAM is congruent to triangle CBM, right? And that is because of RHS. And if we just check, sanity check, CA is equal to CB, yes. AM is equal to BM, yeah, that feels right. CM is equal to CM, that's the common side. Right, so it's time to shrink some stuff. I really am not in the mood to go to the next page just yet. The party's just getting started. Okay. Okay, so now we have proven that the two are congruent. Okay, anyway, we don't even need to prove that just yet, but we'll keep it handy for now. So equation of line AC will be given by y is equal to 3x plus c, right? They've given us the gradient of the line, so we know one piece of the puzzle. So to find the other piece of the puzzle, we're going to sub in the point C to find C. Ha, ha, ha. So the y is equal to 3, the x is equal to 6. And so that means 3 is equal to 18 plus C. So C must be minus 15. So therefore, y is equal to 3x minus 15, right? So now that we know that, don't take other things with you. Oh my goodness, my E lost its hat in the crossfire. Okay, so now we can use that. Therefore, to find A, we are looking for the x value that gives us a y of 0. So 0 is equal to 3x minus 15, and you can just kind of visually see that x must be equal to 5, right? 3 times 5 is 15, minus 15 is 0. So now we know that A has the coordinates 5, 0, right? And why is that? iPad nearly fell out of my hands. You are uninsured, iPad. You are uninsured. What is the plan? To bring me misery. That's the plan. Anyway, so now that we know that A is 5, 0, now we can say that means BM is equal to AM, which is the difference here, right? No, not a picture. Okay, we went from 5, 0 to 6, 0, so we moved 1 unit. Okay, so, and that's because of the congruency that we proved, right? CAM is congruent to CBM. Okay, Right, so then that means the coordinates of B are going to be 6, 0 plus 1 unit horizontally. So that will be 7, 0. And now that we know B, right, so we now know that B is 7, 0. So we can figure out the equation of the line, right, by using these 2 points. So, okay, so to find the equation of BCD, use B, which is 7, 0, and C, which was 6 and 3, I think. Yep. Right, so first we'll find the gradient of this line, which is 0 minus 3 over 7 minus 6, which is minus 3 over 1, which is minus 3. So it's going to look something like this. Okay, and then we can sub in either point. So let's sub in the very easy one. Sub in B. So 0 is equal to minus 3 times 7 plus C. Okay, so 0 is equal to minus 21 plus C, which implies that C is equal to 21. And so as a result, hey, Kalki, wow, so eagerly even sliding out. Wow. Okay, so that means the equation of VCD is given by y is equal to minus 3x plus 21. Okay, and of course you can put in the other point just to be sure. So minus 3 times 6 is minus 18 plus 21 is indeed 3, right, which is what we have over here. So for fun, as promised, let's try and do this algebraically, or more algebra intensively. So we duplicate. There. Hey, what did I duplicate? Oh, there it is. Sorry. Yeah. Hello. You didn't move, my friend. Okay, that's better. Okay. Right, let us erase. After the rain and snow, there will be time to love again. After the rain and snow, there will be time to laugh again. After the rain and snow, there will be time to love. Is it love or laugh? I don't know actually. So let's get rid of all the stuff that we filled in with our big brains. Okay, so just to recap what the first plan was, the OG plan. The OG plan was, I am going to find the equation of this line because we know its gradient and we know a point on it, right? Then from there, what was I going to do? I forgot to note. Oh, okay. So after finding the equation of that line, I was going to find the equation of, not the equation, the coordinates of A, right? So that I could figure out the length of this line. Then I was going to come here and say, okay, B, I know that your y coordinate is 0, but I need to figure out your x. So I'm going to use the distance formula again because I know the length of this guy and you have the same length. So I can use the distance formula to figure out your x coordinate. So let's do that. Right, so it would again be, we want to find the equation of AC, which will be given by y is equal to 3x plus c. Right, so these steps are pretty much the same as, when we did this earlier. So I sub in my c, so y is equal to 3, x is equal to 6. Okay, I'm not going to talk much because even my throat is just drying up here. Y is equal to 3x minus 15. Right, so that is the equation of this line. Right, so now to find the to find the coordinates of A, right, we'll say we know that the y coordinate is 0, okay, and then can add 15 on both sides, so therefore x is equal to 15 divided by 3, which is 5, right? So therefore the coordinates of A are 5, 0. Okay, time to shrink. Okay, right, so we now know that this is 5, 0. Then we can find the distance AC using the distance formula. So that will be 3 minus 0 squared plus 6 minus 5 squared. So that will be 9 plus 1, which is a 10. So the length of AC is square root of 10 units, right? So now we want to figure out the other value of x for which the distance from C will be root 10, because we've been told that these are equal. So AB is, okay, so firstly we know that B has coordinates some value of x, let's call it B, right, and the y coordinate is 0. And we furthermore know that AC is equal to BC, we were given that, right? Time for a new page. Okay, so now we can say, well, BC is indeed root 10, right, by this logic of ours. So we are saying the distance between B and C, so we'll say 6 minus B squared plus 3 minus 0 squared, and we're saying that that is going to be equal to 10, right? And the only way that that can be true is if the thing underneath the square root is indeed 10, right? So 3 minus 0 squared is 9. Okay, so basically we are looking for values that will make 6 minus b squared equal to 1, right? Because 1 plus 9 is 10, right? So that could mean that 6 minus b is positive 1, right? 1 times 1 is 1, or 6 minus b is negative. Negative 1 times negative 1 is also 1, right? So in this case, b is equal to 5. And in this case, b is equal to 7. But we already have the b is equal to 5 solution. That's A, right? So that's the one point on the x-axis that is root 10 units away from C. The other one is 7, 0. Okay, so we can say here, but we know that b is greater than 5, which is the x-coordinate of A, right? So therefore we have then B having coordinates 7, 0, and now we have, so that was just another way of getting the coordinates of B, and then from there we can do the same process we did before, right? This process to find the equation of BCD using these 2 points. Okay, and then use B and C to find equation of BCD. Right, okay, nice. Oh, time for a position change. The elderly bones. Right, so the next question says, determine the equation of a circle with DA as the diameter. Oh my goodness, what is happening? What do you mean? Never. This line is not even trying to understand. Okay. Yeah, something like that. then what would the circle look like? It's the circle. Aibo, why did you decide that you're a line now? You're a circle, my friend. The circle of life. That is not a bad attempt. Honestly, I am not even vaguely mad at myself for this one, Shem. Okay, but now the mystery is, how do I rotate this thing? Because now it's not really giving diameter at this point. Hey, when a circle. Hey, whoa. Okay. Yeah, you need to shrink a whole lot, my friend. Something like that. Oh, hi, this diameter is not giving diameter, Shem. Hey, circle. Come on. I'm just trying to perfect you a little bit. Just a little bit. Okay, let me not be greedy. Anyway, right. So we are looking for the equation of the green circle. Okay. So first things first, we need to know the center of the circle. So we need the midpoint of this line. We have the coordinates of D in a way, because we know that the line BCD is y is equal to minus 3x, and I think it was plus 21, or what? Minus 3x plus 21. Yo, my memory sometimes has some promising moments. So as a result of that, we know the coordinates of D because it's the y-intercept. We know that it's 0 and 21. And we know the coordinates of A is 5 and 0. So we can find the midpoint. Okay. And then from there, the other thing we need is the length of the radius. Radius, whoa. And here it would be, actually, I think the easiest thing would be to find the length of the diameter. Like the points are so nice. They have 0, 21, 5, 0, you know. So the finding the distance between these two is going to be so nice, because you're pretty much just doing Pythagoras. Like this is 21 units, this is 5 units, and then you're finding the hypotenuse. And then we know that a diameter is equal to 2 radii. So let's go. So first things first, we are going to find, so we know that A is 5, 0. Okay, and D, wow, what is happening? Where am I getting helium voice from? Okay, because it's the y-intercept, you know. Right, so therefore the midpoint of A and D will be given by 5 plus 0 over 2 and 0 plus 21 over 2. Ugh, weird numbers. Ugh. Right, so the midpoint of AD will then be 5 over 2 and 21 over 2. Right, so that's the first thing. Then the next thing is, okay, what is the length of the diameter? Right, and of course you could also just work out the distance between the center and either A or D, right? Anyway, so this is 5 over 2 and this is 21 over 2. Right. So the distance AD, so I'm going to say AD squared is equal to 21 squared plus 5 squared, right? Because this part is the 21 units and this part is the 5 units. Okay, and that is a right angle. So this is true because Pyth said so. Things are getting mixed masala here now. Okay, right. This is not giving, I know, this Pythagorean triple at all. So I'm going to suspect that it is indeed going to end up being some irrational number. It's so hard to work with those numbers. They don't give you space. Right, and we know that it's only the positive square root because we're talking about a distance, so it can't be negative. Let's see what it has to say for itself, this square root. Okay, so 21, 5, 8. Why am I feeling like maybe I made a mistake somewhere? You know, when I get numbers like these, I get nervous. I get so nervous. I have a feeling I've done something wrong, and I'm going to cry if I have. I will cry. Anyway, okay, we don't actually need we don't need this. We don't. So I'm going to leave it like this, because when we write the equation of the circle, we're going to write r squared. So the sturdiness will be, eliminated. Right. So, therefore, the radius of the circle is half of root 466, right? And so the equation in total is x minus 5 over 2 squared plus y minus 21 over 2 squared is equal to root 466 over 4 squared. Whoa. And then obviously we want to write that a bit more nicely. So that will be x minus 5 over 2 squared plus y minus 21 over 2 squared is equal to 466 over 16. One more time. This minus is given up. But from Zim. Go away. Thank you. Okay. Right. 466 over 16. So 16 goes into 46 twice. Remainder 14. 16 goes into 146. Goes into 1449 times. And so then there'll be 2 left. So it'll be 2 over 16, which is 1 over 8. Okay, I am almost positive. Almost positive that I've messed up some number somewhere. So let's just look at this from the top. But I got the same answer using different methods. So how wrong can I be? Really? Let's see. Maybe let's just test if y is equal to minus 3x plus 21. We did see that that does work for 3. Minus 18 plus 21 is indeed 3. And the other equation was y is equal to 3x minus 15. 3 times 6 is 18 minus 3. Hey! Yeah, is equal to 15. 3x minus 15 is equal to 3. What am I saying? Let's go back. Stop paravading here. So over here we said 3 times 6 minus 15 does indeed give us 3. Okay. And then now, what's the other numbers? So now, to work out the equation of this circle, I use the fact that this is 5, 0. And we know that I double checked that. That is indeed, okay, so this is 0, 21, yes. This is 5, 0, yes. The midpoint will be that. AD squared. Yeah, guys, I think I'm going in with this one, with this weird looking answer. Let's see. Are you ready to cry with me if I've double checked? I've done a whole double checking and I'm still wrong. There's nothing that hurts. Hurts my spleen. Hurts my pancreas. Yeah, it's a deep kind of pain. Okay, so let's see. Question 8. Evan, people are using trigonometry even. Oh, that's a nice one. That's actually a nice one. So, how you could use trig. We're looking for the equation of this line. Oh, so you can use trig because this is a gradient of this line, so you can work out the angle of inclination. And it's an isosceles triangle, so then that gives us this angle. And then you can work out this angle using angles on a straight line, and then find the angle of inclination for this guy, which can give you the gradient, which you can then from there you can put in this point to figure out C. Either way, we arrive at the same place, eh? But nice. That's a nice, much shorter solution, actually. Now for the moment of truth. the other one. Oh, guys, it's looking promising. It's not completely, we aren't completely in agreement though. So let's see where we're not agreeing. So here they found the coordinates of A, which we also found to be 5, 0, and D is 0, 21. Yes, we agree. The center of the circle will just be the midpoint of DA, which is indeed 5 over 2, 21 over 2. Sharp. Now, to find the equation of the circle, they just sub in 5, 0 into the equation to find R. What did I do? I used Pythagoras. And where did Pythagoras get me in life? Where did Pythagoras get me, y'all? Anyway, so I ended up with 466. Oh, hey, where did I get this? Why didn't you tell me? Where did I get this for now? So let's fix that up. So this is root 466 over 2, as in this number, not the number that I just randomly made up. And then this is 466 over 4, right? If you do the squaring. And then now we're speaking sense. 4 goes into 4 once, 4 goes into 6 once, remainder 2. 4 goes into 26 6 times, remainder 2. So then we have our half. And they also have their half. Okay, not bad. Not bad. My ominous feeling did not materialize as catastrophically as I thought it would. Wonderful. So yeah, so they didn't even go into this whole mission. What they did was they just from here went straight into equation mode. Okay, and then they said we know a couple of points that lie on this circle, so we're gonna sub in either one really. So you could sub in A or you could sub in B, so D. So D would be 0 minus 5 over 2 squared plus 21 minus 21 over 2 squared is equal to R squared. And then of course our calculator, which has been waiting to show up, well, I guess I just used it, so let me not be dramatic. Right, squared plus 21 minus 21 over 2. Hey. And we square that one as well, right? And then that gives us our R squared, which is 116.5. And yeah, potatoes are potatoing as a result. Right, so that's that on that, kids. Thanks for tuning in. It's always such a joy to have these chats that feel solitary but really aren't. And yeah, I hope that you will swing by again for another nostalgic ramble. Ciao.